Additive manufacturing. Myself, Dr. Suman Das, Professor, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. So, additive manufacturing, that is code is PEME 802F. So, in this video, I will discuss the discrete particle system. So, discrete particle system, first we explain what is that. Discrete particles are normally powders that are graded into a uniform size and shape and narrow distribution. The finer the particles, the better, but there will be problems if the dimension get too small in terms of controlling the distribution and dispersion. The conventional 1D channel approach uses a laser to produce thermal energy in a controlled manner to raise the temperature significantly to melt the powder. That means a laser power is used to melt the powder that is size is too small and that is uniform. Polymer powder must therefore exhibit thermoplastic behavior so that they can be melted and remelted. That means thermoplastic materials that is having the characteristics that can be melt and also remelt to permit bonding of one layer to another. So first one layer, after that another layer, so that having that capability for bonding with the previous layer. Now the two main polymer based system commercially available are, that is selective laser sintering, that is SLS technology, marketed by 3D System, and the second one is the EOSing process by the German company EOS. Now 3D Systems selective laser sintering, that is SLS. What is the principle? The principle, the parts are built by sintering when carbon dioxide laser beam hits a thin layer of powder metal. Next is the interaction of the laser beam with the powder raises the temperature to the point of melting, resulting in particle bonding, fusing the particles to themselves and the previous layer to form a solid. The building of the parts is done layer by layer. Each layer of the building process contains the cross section of one or many parts. The next layer is then built directly on top of the sintered layer after an additional layer of powder is deposited via a roller on the top of the previously formed layer. Now, what is the procedure? The SLS process create three-dimensional objects layer by layer from CAD data generated in CAD software using powdered materials with the heat generated by carbon dioxide laser. CAD data files in the STL file format are first transferred to the system when they are sliced. SLS process starts and operates as follows. So this is the laser. That laser is coming through the lens and through the deflector that is entering, and that is that melts on the powdered material. So that is the XY scanning mirror. This is the laser beam. This is the sintered part, and this is the powder bed. And this is the lower. When completion of the laser system from producing one layer, when it melts the layer, so the roller is passing over there, so another thin layer of powder is lying on that the layer, and so that will, after melting, that will attach with the previous layer. So this is the powder feed supply. And this is the build piston. So that build piston is gradually comes down, and this is the powder feed piston that is gradually moves up. So in this way the entire product will be produced. Number one, a thin layer of heat fusible powder is deposited into the part building chamber. Number two, the bottommost cross-sectional slice of the cat part under fabrication is selectively drawn or scanned on the layer of powder by heat-generating carbon dioxide laser. Number three, the interaction of the laser beam with the powder elevated the temperature to the point of melting, using the powder particles to form a solid mass. Yes, if you see the diagram, so this is the energy input. So this is that is the powder particle. So this one the powder particle, and when the laser is passing through this, so that laser will melt the powder particle. Number four, the intensity of the laser beam is modulated to melt the powder only in the area defined by the parts geometry. So only it will melt the particular region, particular area. So the surrounding powder remains loose, compact, and serve as support. So there will be no effect of the surrounding powder. So that will act as a support. Number six. So when the cross section is completely drawn, an additional layer of powder is deposited via a roller mechanism on top of the previously scanned layer. So this is the laser beam, this is the XY scanner system, this is the laser beam is coming, this is the powder bed, and this can be moved gradually down, and with the help of roller the powder material is laying over the previous layer, and after melting off with the help of laser, so the new layer will be attached with the previous layer. So this will be continued until the entire product is formed. This prepares the next layer for scanning. Step 2 and 6 are repeated. So step 2 and step 6 are repeated with each layer fusing to the layer below it. So this is the entire process. So the successive layer of powder are deposited on the process is repeated until the parts is completed. So this is the diagram. So this is the laser scanner deposition. This is the chamber. So this will be fused, and the next, the another, with the help of roller, another powder material will be deposited on that layer. So in this way, this entire system is going on. So if you see the diagram, so the diagram looks like this. So already I have discussed this one. This is the laser, this is the scanning system, and the laser beam is coming that will hit the powder, and the powder will be fused and it form a layer, and that, and this is the base plate. Then base plate will comes down, and with the help of roller another powder material will be deposited on that, and that will be fused, and that will attach with the previous layer. In this way the entire product will be produced. Yes, this is the picture, entire picture. Thank you very much.